Hello everyone, my name is Tudor Urdesh. I'm working for CyberArk as a DevSecOps subject matter expert, and I would like to focus on a very specific topic related to our main secrets management solution, which is called Conjur. And I will show you how you can scale up Conjur followers using the Openshift built-in horizontal pod autoscaler feature. I'm sure most of you are already familiar with Conjur, and I will skip the important part related to our solution, and I will focus, as I mentioned before, only on a very important subject, but it's very specific. So Conjur is our main centralized secrets management solution, which can be used to secure CI/CD pipelines, secure containers, secure your application deployed inside Openshift, and it has a unique architecture. It's a top-to-down architecture. As you can see in the first part, we have the CyberArk Enterprise Vault, where you can host and save in a secure way your human or non-human identities. We are focusing on non-human identities. You can store accounts, API keys, SSH keys, certificates, everything which can be used by an application. Your secrets will be synchronized to the Conjur leader, which has a standby server and, of course, a disaster recovery site. Those secrets will be replicated to the followers. What is a follower? A follower is a read replica of the Conjur leader, and it will consume and retrieve only the secrets which will be used by your application. So you can define and you can deploy the follower inside an OpenShift cluster, a Kubernetes cluster, or outside the Kubernetes cluster to serve a unique application or a set of application pods under a specific namespace. For example, if you have an application, a pod deployed in a namespace, instead of connecting directly to the Conjur leader, it will be able to connect to his own specific follower. Or you can have a follower serving multiple applications under the same namespace. The main idea is, from high availability point of view, is the following. Let's imagine your entire Conjur cluster is down for some reasons, and also the disaster recovery site is down. Your applications will continue to work and consume secrets because you still have the followers. So as long as the followers are up, there will be no downtime for your application. So you'll have enough time to restore your Conjur leader, Conjur cluster, or the disaster recovery site. So we are using the followers for high availability and also for low latency, because a follower will reside in the same namespace with your application, so there is no latency. And you have multiple options to deploy those followers. One of them is by using the Conjur Openshift operator. So an operator is an easier way to pack, deploy, and manage different Kubernetes native applications. We have a strong partnership with Red Hat, and as a result, we deployed and we published our own operator, which is called Openshift Conjur Enterprise Operator. It can be searched, can be found on the Openshift cluster itself if you go to the OEM marketplace or hub. So using the Openshift operator, the Conjur Openshift operator, you'll be able to deploy those followers, which are read replicas of the Conjur leader, inside your cluster. Of course, we support multiple authentication and authorization methods. My favorite one is by using the JSON Web Token authentication. And in this specific example and demo, I will show you how you can define some parameters inside the operator, follower, and how you can use the horizontal pod autoscaler in the same time. Basically, by using the HPA, which is by default enabled in Openshift, most of the time, otherwise you need to enable it, you can define some limits, some metrics specific to your pods. In our case, our pods will be represented by our followers. For example, if a follower serves multiple applications, and the resources assigned for that specific follower are exceeded, you can use HPA to scale the followers up or down based on your needs and based on your application needs. So basically, if you have allocated memory of 500 megs, if a follower will overpass that, by using the HPA, the horizontal pod autoscaler, there will be a new follower which will be spin up automatically. So you don't need to worry anymore about these important aspects. And of course, by using HPA, we can also take into account the CPU utilization. Now let's move to the demo. Let's start with the fun part. As we can observe, I have my own CyberArk Enterprise Conjur instance, which is up and running. I already defined my authenticators. I've loaded some policies and some secrets just for demo purposes. As we move to the official CyberArk docs, we can observe that the JSON Web Tokens authenticator is just a YAML file. You can use our template, and you need to load the file to Conjur in order to recognize our Openshift cluster. We loaded some informations retrieved from the Openshift cluster, like the public keys, the issuer, and Conjur, based on those information, will be able to say, yes, you have a valid cluster, which should be allowed to retrieve secrets consumed by your applications. There is an additional file, which is called seedgeneration.yaml. Of course, you can name it however you decide. The main idea is by using this simple YAML file, our followers will be auto-enrolled in Conjur. Just remember, before everything, you need to enable the JSON Web Token Authenticator, the YAML file. You need to enable the seedgeneration.yaml file only once. And of course, you need to provide and specify an identity of your associated with your application deployed inside Openshift. We use multiple claims, which are specific to JSON Web Token authentication. One of them is called audience. And by using those claims, we can even prevent impersonations of the applications inside the cluster. If I'm moving to my Openshift cluster, as you can observe, it's a real Openshift cluster with 3 master and 3 worker nodes. And if I switch to the operator hub, as I said before, in order to deploy Conjur followers, you can use multiple methods. You can use Helm, you can use, in our case, the operator, the Conjur Operator, which can be found under the operator hub tab. It's a simple process. You just press next, next, next. You can choose how you like to, how the updates should be applied automatically or requiring manual approval. And once the operator is being installed, it will appear here under the installed operators. In my case, I will spin up a follower. Of course, I will not go in very specific details, but you can understand the main idea. The first step will be to name my follower. I will call it app-pet because I already let Conjur know that this will be the name of my follower in a policy. I'll use my Conjur account, which represents the actual name of the product, how I decided to name it on my site. So I name my Conjur instance POC-Conjur. I've used my authenticator and I've named it like this, dev-cluster-rh. Just remember that it can be /production, /dev acceptance, etc. For demo purposes, I choose to name it like this. So if I switch back to the policy, as you can observe here on the second line, my policy is called conjur/out-jwt /dev-cluster-rh. I need the public certificate of Conjur. I already loaded in a config map, so it's very simple just to refer using this key. I will need my Conjur leader address. Remember the HTTP address. Remember, in production, you'll use a load balancer, so you'll instead of using directly the Conjur leader HTTPS address, you should use the load balancer address. I need to copy it from one of my files. Copying my own Conjur leader address, HTTP address, I need to populate with the audience value. This represents a claim which should be unique. The value inserted here should match one-to-one with the one defined in Conjur. In order to prevent impersonations of the applications, you should have unique values for, in my case, for each follower. The authentication method, it will be JWT, so I need to change that. I don't need an application identity for JWT authentication. I also need to load a configuration file to let my follower know that JWT is being enabled. All those informations are on our website, so I'll not go in a lot of technical details. Here, under the Kubernetes resources, I'll use a service account specific to my followers. So it's called like this. And the most important part is related to the container resources. Most of the time, if you want to test it, in pre-production test acceptance, you actually don't need to set some limit because the actual follower product, it doesn't pack a lot of, it doesn't require a lot of resources. But in production especially, you should define some limits. So in my case, for exemplification, I'll set my upper limit for my specific follower 500 megs. I will just put the same value for all the containers which will be retrieved by the operator. So I'm restricting my follower to use maximum of 500 megs. Of course, you can limit the CPU cores, the request, the storage, etc. Once everything is set up, I'll press on create. You'll see the follower under the Conjur follower tab. It's called app-pet. It's on green, the status is ready. Now if I move to the pods, as you can see on the first part, my follower is already up and running. It's downloading the required files. I can check everything live, so if I go to logs configurator, I'll be able to see that my follower successfully authenticated to my Conjur leader. Everything is loading, don't see any kind of issues. If I move back, yes, now my follower is up and running. And it's using almost 180 megs. And if you can check here on the install operator, you also have the option, if you decide later on, to spin up more followers, more replicas. So in my case, if I want to have 2 followers, I can do it manually. But just remember, because we are trying to implement the HPA, we'll set an automatic way in order for this process to happen automatically and to spin up the followers based on the resources used. So if I decide, for example, if I will have 50 different applications, the memory or the CPU of the follower will increase, not a lot, but it will increase. And using the Openshift HPA, once we hit a set limit, for example, for memory, we can say once the memory hits the limit of 300 megs or the CPU allocation, the Openshift HPA will spin up automatically another follower. Of course, you can define to scale down once we solve that high peak. Okay, so manually I spin up 2 followers, but I'll show you now how you can do that automatically too. Let me go back to my Conjur follower and limit the replicas to only 1. You can also observe that the limits I already set are present here, so 500 megs. Now I have only 1 follower up and running. By the way, you might see that I have here a red warning. This is my application, but because I've installed a new follower using a new operator, you'll be able to see this error. My application is very simple. I will not go very deep from technical point of view, but it's using a follower, the follower address, which is having this format conjur minus follower dot tudor minus jwt, which is my namespace, service cluster local / API. So my application, instead of connecting directly to the Conjur leader, it will connect to the follower locally. And because I spin up the follower near my application, as you can see, there is no latency, and my application already started to be up and running without doing any changes. On the left side, you'll be able to see the horizontal pod autoscaler. For demo purposes, I will create a new horizontal pod autoscaler, and I will use some values. For example, I define a template. I replace the current one. You can define multiple parameters. If you go on the Openshift website, you'll be able to see all the parameters, the behaviors which can be set when, at what value pod or follower should be spin up or down, what will happen after that, etc. For demo purposes, I will set the max replicas to, let's say, maximum of 3 followers. And to force doing that, instead of inserting a normal value like 280 megs, I will set it to 100. In this way, when my HPA will start, it will observe that my pods, my followers, are already using 280 megs from my memory, And of course, because I set a value of 100 megabytes, which is under the actual normal value, it will start to spin up 3 followers, or let's say 4 followers. I believe it's enough. Okay, so I'm creating, based on the rules I set. If I go to the YAML, yeah, it's starting. In a couple of seconds, I should see some activities under the conditions here. Okay, so it's loading. The first one is false, is normal. The object has been modified. And if I go to the pods, as you can see, it already started to spin up followers. Initializing, so I set 4 followers. This was the original one. And now it starts one by one to load balance the memory usage. It will spin up the rest of the followers, one by one. If I go to my application, if I go to YAML, this represents the address of the follower. So in case if I stop all the followers from spinning up, I can do that manually too, or by using the HPA. For example, now let's delete it. I will delete it. If I go back to the install followers, to Conjur followers, path, replicas, let's put to 1. Now I still have, I'm back to 1 follower. And if I redeploy my test application, edit pod count 0. Let's put the pod count to 1 again. You'll see that even if I'm not using anymore the original follower, it was one of the new spin up followers, my application will be able to run because the follower address stays the same, even if you spin up 10, 20, 100 different followers. So the follower, which is a read replica of the Conjur master, will authenticate to the Conjur leader. You can also check that in the logs. Will retrieve the secrets, and my application, using secrets provider, will use those secrets and populate my Kubernetes secrets objects. So if I'm going to my secrets, to DB credentials, those values are coming directly from the Conjur leader. And I can do a live testing right now of my password. Let's say something very random. Remember, in production, we have the CyberArk vault where you can store those sensitive informations. The actual value of the secrets will be synchronized to Conjur automatically, and from Conjur will be consumed by our tools, clusters, application, etc. So I've changed the value, and now if I go back to my secrets, the value should be populated by secrets provider under here. As you can see, the change was in real time. I can do it very fast right now. For example, I put 1, 2, 3, 4, 5, 6, etc. And now the change will be reflected in real time also at my Openshift level. If I go back and I press on DB credentials, you can see the password was actually updated. I've done a manual rotation, but I will not repeat myself. In production, we have CPM with automatic rotation. We can rotate the values each day, each month. Everything is monitored and logged. But just for testing purposes, I can show you the flow that my application using secrets provider is able to connect to the follower which was spin up automatically using the operator and HPA, and my application using the secrets provider as one of our methods to retrieve secrets will populate my Kubernetes secrets objects with the value coming from Conjur. So the entire flow is working flawless, end to end. In this way, what I've done right now was to spin up the followers, the read replicas of Conjur leader, followers which can spin up or down manually or automatically by setting up the HPA. So if you decide to limit the memory allocation, or if you want to insert a safe limit for memory or CPU, you can rely on Openshift HPA to spin up those followers pods up or down based on the workloads. And my application, which is using secrets provider, one of our methods to retrieve secrets in a secure way and to populate your Kubernetes secrets objects, it will connect to the follower, which is already doing the authentication with the leader, with the Conjur leader. So my application is connecting to this follower, will retrieve the value of the secrets, will populate a Kubernetes secrets object. In this way, you can have rotation in place, and also the monitoring part, which is built in the actual product in Conjur. If I go to the dashboard, I'll be able to see exactly all the activities done under my Conjur cluster, and you can also observe the human activity too, and also the secrets which were retrieved by my application. For example, my password was fetched successfully and used. So if I go to the host, this is an identity defined only for my specific application. You can see that everything is monitored and logged. And there is another important part that needs to be mentioned. Once you define the horizontal pod autoscaler, just remember you need to use the conjur.cyberark.com API, and you need to refer it instead of a deployment or a replica set. You need to define the kind, which is Conjur follower, and after that you can actually provide the name of the follower which was created using the operator. And of course you can add more important things to be checked, like the CPU or memory or even other important aspects like HTTPS requests. A lot of examples are on the Openshift, Red Hat Openshift website. Everything is public, so you are able to create your own HPA limits and triggers for your followers. Thank you very much, and I wish you a great day.